Finding a Star 2, Declination and Your Private Meridian. I am Dr. Midway. I am a physicist, and I'm learning astronomy. In a few videos, I like to share with you how to find a star by reading its coordinates. The celestial sphere is rotating. Earth doesn't move. You probably noticed we're using geocentrism. That's you, the observer, standing on equator, pointing your finger up in the sky, find your zenith point. Now, pointing to the north on the horizon, and then sweep to the zenith, and then sweep to the south on the horizon. That is your own observer's meridian. Think about you stay a whole night there, and what you will see in the sky. The location now is on equator. I set the latitude to 0. This is north. You can see the Big Dipper and those two stars pointing at Polaris, but somehow it's blocked. I'm going to turn on the coordinates so you can see the north celestial pole is here in the north. Okay, turn it off. I'm going to speed up time. See, it's moving from the east and settling down in the west. Let's go to see the west side. It's settling down, right? Everything. In the south, see this is the east side rising, settling down in the west. On the east side, everything is rising. Now it's the daytime. I turned off the atmosphere, so you still can see the stars in the daytime. Now I'm going to change the fisheye. Let's see where's the observer meridian. From the horizon, the north on the horizon, to the highest point in the sky, because this is the fisheye. So the center is your highest, your zenith point, your finger pointing above you. And to the south on the horizon, so this is your observer meridian. Every star in the 24-hour will pass this meridian. Let's go a little faster. See, everything will pass this line, imaginary line, your observer meridian. In theory, on equator, an observer can see all the stars. I found this really cool equatorial map of constellations. The x-axis and the y-axis are right ascension and declination. I found the dog star, Sirius, right here. Now you're on the top of the world. You know your zenith point. Then where's the observer's meridian? I'm not quite sure, because you're at the North Pole, and every direction is south. How about I just draw a line like this and assume that's our observer's meridian. Now guess what you will see at night. The location now is North Pole. I set the latitude to 90 degrees. I'm going to fire up the time machine, make it go fast. Then you will see what happens. Okay, that's fast enough. I'm going to change to the fisheye view, so make it easier. See, everything is moving around the center point, Polaris, the north celestial pole. The Big Dipper, see, it's pointing at the Polaris. Okay, now I feel a little dizzy. I'm going to stop it. In the North Pole, we can see only half of the celestial sphere. In 2005, as off topic, the USS Charlotte poked through the ice in the North Pole. I didn't know submarine can do that. I'm glad I picked the North Pole because in the South Pole, you may fall off from the Earth. Ha ha. Back to Twin City now. The latitude is 45 degrees. What is the observer's meridian? By definition, we point to the north on the horizon and sweep to the zenith point and then move to the south on the horizon. That is observer's meridian. We're between the North Pole and the equator. It's getting interesting. We have two different parts on this meridian. The top part, we can see the stars the whole night rotating around Polaris, which is here, and down below, we can only see the star rising from the east and set in the west. We cannot see them the whole night. Also notice there is a part in the south celestial sphere, the bottom part we just cannot see unless we move south. Let's now see a screenshot video. The location now is latitude 45 degrees. This is north and Big Dipper here. Those two stars, you line them up, pointing to Polaris. Let me turn on the grid, the coordinates. See, North Celestial Pole. And Polaris is very close to it. Turn it off, speed up the time so the star can start moving. It's moving around the North Celestial Pole, the Polaris. Okay, now I'm going to turn to the fisheye view. So it's all rotating around the Polaris here. And where is the observer meridian? North on the horizon, celestial pole, your zenith point in the center, your highest point when you are outside. South on the horizon, you draw a line. That's your observer meridian. And the star here will pass twice a day. And at night, you can see them all the time. But the other stars will rise from east and settle in the west. Let's go a little faster. And on the other side, imagine under the ground, there's a south celestial pole. The star around that area we just cannot see. Here's a beautiful picture of the Twin Cities. The Twin Cities, located on the 45th parallel of the north latitude on the surface of Earth, run through this border. This is a monument in Twin Cities. The distance from here to North Pole or to the equator are both 3,102 miles. That is 5,000 kilometers. Why is it a 5,000 kilometers? There's a story behind it during the French Revolution. Now, back to the declination. After we learn the observer's meridian, it will be easy to find Sirius by angle of declination. Suppose we are outside in the Twin Cities with a latitude of 45 degrees. The easiest point to find is zenith point. So we first point finger above to the zenith point, and then we sweep either north or south along our observer's meridian. In this case, we go south 45 degrees and then 16. So total we go 61 degrees south from zenith point to here. Then we can find Sirius passing it within 24 hours. We do need to know when a celestial object passes the observer's meridian, it is at its highest point in the sky for that observer. I'm going to show you what it means. Let's take a look, see how Sirius passing the observer meridian. First, from south to north, goes through the zenith point in the center, goes through the Polaris. That's our observer meridian. Remember, it's a vertical. So I'll try to keep it a vertical while make it larger. So this vertical line is our observer meridian. So now I'm going to make it bigger. See, this is the -10 the line of declination. And this one is minus 20. So minus 16 makes sense, right? For Sirius. Now you're going to watch Sirius rising. Now it's the winter time, December. It's 8 o'clock in the evening. You will see Sirius rising and then settle down in the west. Okay, it's rising now, become higher and higher. Remember our observer meridian is here. Now it's still getting higher. Passing observer meridian, now become lower. So when it's passing the meridian, observer meridian, it is at the highest point. Now it's sighting. And the same thing applies to all the stars. When they're passing the observer meridian, it's at the highest point. Let's practice on Polaris. Polaris has a declination of 89 degrees. Raise your arm above your head and a pointing finger at the zenith point, and then you sweep to the north on observer's meridian by how much? 89 minus 45. Then that's Polaris. It always stays there because it happens to be on the axis of the celestial pole. Another practice, Betelgeuse. It has a declination of 7 degrees north. Raise your arm above your head, point your fingers to the zenith, and this time you need to sweep south. By how much? 45 minus 7, 38 degrees. Within 24 hours, Betelgeuse will pass that point at its highest position in the sky. By the way, Betelgeuse is a funny name. I don't know what's in your mind, but every time I say it, I start to think about drinking juice in a people's car. Here's the summary. We see latitude and declination in the calculations, but it's not consistent. The declination plus latitude, declination minus latitude, and the declination being subtracted. Now we need a math. Let's set up a rule just like the plus minus sign in latitude. We say from zenith point, we go north if it's a positive, and we go south if it's a negative. The first one we look south, so it's negative, so we change the sign on the expression. The next one is positive, we go north, we don't need to change anything. The last one is minus, so we need to rearrange. Now we have a declination on the left side and a latitude on the right side. It's consistent. Now we have a procedure. We start by pointing finger to zenith point and use declination to subtract latitude. And then from zenith, trace along observer's meridian. Go south if it's negative, north if it's positive. And now we can tell the direction and where Homer should go. In the end, let's try to find the Proxima Centauri. That's the closest star outside the solar system. The declination is negative 62, and a negative 62 subtract latitude 45, we have a negative 107. From zenith point, move south by 107 degrees. Oops, that's under the ground. So at a 45 degree in the Twin Cities, we can never see Proxima Centauri. We have to move south. This is a picture of Proxima Centauri. It is a dot inside this red circle. If one day our sun dies, we'll have to put the engines on Earth and move Earth to Proxima Centauri. In the next video, I will start to introduce right ascension. If you like this one, please subscribe, like, and comment. Thanks for watching.